Okay, so this video is looking at Venn diagrams, which might be something that you started off doing in primary school and we're now revisiting. Um, so quickly, some notation which you may not be familiar with. In this video, I'm going to talk about union and intersections. Union is where we have this U-looking symbol, and basically this is the union of A and B, or another way of thinking of it is using the word or. Intersection, uh, looking at this one, this shape here replaces and, so A and B, or the intersection of A and B. So it is worthwhile remembering it. The easy thing, obviously, this looks like a U, so it fits with union, and this is an intersection. This is an N, so it fits with intersection. So, first thing we need to do is define variables. So, in generally a lot of the examples we give, we use A and B. So each of those represent a variable or something. So we've got a question here. The variable A is looking whether a student's in a maths class. B is whether a student is in an English class. And we've talked about union and intersection. So if I have a student and I apply those variables, there are four possible outcomes. So either a student does maths and English, either they do maths not English, not maths but English, or they do neither. So there's A or B. So, or the union of A and B means that a student is in maths or English. We have A and B, or the intersection of A and B means that a student is in maths and in English. So notice the subtle differences between the implication of and or. So with or, that includes people who do maths and not English, as well as the people who do maths and English. The other thing is a little dash here. We can quickly change any of the variables to their complement, which is the opposite. So the complement of rolling a 6 is not rolling a 6. The complement of being in a maths class is not being in a maths class. And of course, that's different from being in an English class. So a student is not in a maths class. This one is when it starts to get a little bit more complicated, is we've got the intersection of A and B, but the complement. So not in A and B. You'll be really careful where we apply brackets and groupings, but not A and B. That's different from not A and B. So a student is not in maths and English. Here we've got the union of A and the complement of B. So it's the probability of a student is in a maths class and not an English class. So it might be worth revisiting this page again, because there's quite a lot on there and it might seem a bit confusing at the moment. So what is a Venn diagram? Venn diagram is a way to represent these four areas. So we have an area, so we've got the four areas. We've got area 1, which is A and not B. So if we think about the table we've got here, which would be familiar with the grid, that would be area 1, there, A and not B. Area 2 is A and B. Area 3 is B not A. That would be 3. and area 4 is not A and not B. So if we think of in terms of our example I gave before, so A would be you're in a maths class but not an English class. So 2 would be you're in maths and English. B would be you're in an English class but not maths. And 4 would be that you're not doing maths or English. So the key point to realise is that there's also a section there for adding them up as well. So obviously there's groups bigger than that. So if we think about just the probability of A, that's regions 1 and 2. 1 and 2. And obviously the total probability would be those together. If we talk about the intersection of A and B, that's section 2. Okay, so the union of A and B, and this is one that normally confuses people, is that we're talking about regions 1, 2, 3. And that's when it doesn't matter if you don't have both, as long as you've got one, you're in that grouping. Here we've got the complement of A, so that's everything that's not A. So that's 3 and 4. 3 and 4. We've got the complement of the union of A and B. And the easiest way to think about it is if 1, 2, 3 is A or B, then the complement of that must be everything else. So if we go back a slide, this is when we used the union of A and B. Here it's the complement of the union. That's the same as not A and not B. So there are those sections, and some more of the symbols and things like that. We'll become more familiar with them the more we do them. So being able to label the regions is really important. So the key thing to realize is that sometimes we have Venn diagrams that don't overlap. So rather than thinking about our subject classes of maths and English, if we think about form classes, so it's impossible for you to be in 2 different form classes. So therefore, those if they were A and B, so the probability you're in Dr. Walters' form class or Mr. Hutchings' form class, it's an impossibility because you can't be in both. You can, however, be in an English class and a maths class, so that'd be the difference. If we have a situation like this, it's called mutually exclusive. Things can't happen at the same time. We're going to revisit this a bit later on, but it's a key thing to have in your mind. So first thing we should know whether a situation is mutually exclusive. If it is, it's really easy. Then the probability of A is whatever it is. There's no overlap at all. Probability of B, or we just add them together. So how can we represent A and B? Is that first of all, we need to think about what each group does. So there are 2 sets, 4 regions, and we've got 2 sets. So when it's an intersection, what you have to remember is it's the ones we have to include only the ones that they have in common. So you see here that A is made up of this, and B is made up of 2 and 3. The only thing they have in common is 2. So to represent A and B, that's that. So intersection, they must be in both lists. For the union, they can be all the numbers in both lists. So intersection, they must be common, the same in both lists. Union, they can be both. So if we think about A and B is region 1 and 2, and B is 2 and 3, then what they have in common is 1, 2, and 3. To represent A or B, you need to shade in regions 1, 2, and 3. Okay, the complement of A. So we know A is 1 and 2. So when it's a complement, you do all the things that it's not. So we know that if A is 1 and 2, everything that's not A is 3 and 4. So we shade in that region. How do we represent not A and B? So the first thing, go through the same steps as before. So find out what's not A. So we know that that's not A. We already know that B is 2 and 3. So because it's a intersection, what ones do they have in common? Region 3. So not A and B is region 3. Okay, so there's a lot of work there, but it's not particularly difficult. So coming on to questions, we can have a question like this where we talk about 20 students, 7 are taking maths and 3 are also taking biology, 5 are taking neither. What is the probability the student chosen at random is taking biology? So first thing is we need to draw our Venn diagram. There's 20 students in total. So this is the universe. So it reminds us of that. Our Venn diagram. So the X show maths and biology. So 3 do both is the key bit of information to start with. Next, 5 do neither. So it goes on the outside. 7 do maths, but we have 3 already, and this is the crucial part. So we know that it's 3 already do that, so it must be 4. This is because the number maths is equal to 7, so it must be the 4 and the 3 together. So to work out the final number, we know it's 20, so it must be 20, take away the 4, take away the 3, take away the 5. It gives us 8, which we chuck in there. So that means the probability of that a student takes biology is everything in this egg, which means it's 11 out of 20. Nice and easy. Here's another example. You can give it a go yourself. Just pause the video, draw the Venn diagram, and see if you can get the answer. And we want to know, find the probability that the student chosen at random is a boy and is left-handed. Okay, hopefully you've given that a go. First thing is to define the groups. There's 30 in total. So keys, bits of information, we've got 6 out of the 14 boys. So that means we get 8 and are left-handed, and we end up with 13. Big thing to keep in your mind is that a lot of people make the mistake of making the two groups left-handed and right-handed and not really thinking about it. Remember the event that right-handed is actually the complement of left. So pause this. So get out of this video, go try some questions from your workbook.